Okay, in this final video on the endocrine system, we're going to focus mostly on the pancreas. And then we'll get into ovaries and testes a little bit, and then just wrap it up with some other organs that produce hormones. But this video really focuses in on your pancreas and its involvement in blood sugar regulation. So let's talk a little bit about where the pancreas is located, kind of what it looks like. It's located in your abdomen, kind of your upper abdomen, directly behind your stomach. All right, so it's posterior to the stomach. It's an example of what we call retroperitoneal organ. We'll talk more about that when we get into the digestive system. But if you are retroperitoneal, you're not really in the cavity, in the abdominal cavity, you're behind it. You're in essence in the wall. So it's kind of in the back wall of your upper abdominal cavity. It's a very large gland, but most of it is not endocrine. All right, most of it is exocrine tissue. And the exocrine tissue produces digestive enzymes. So we'll revisit the pancreas when we get to the digestive system, where we're going to see that it produces a lot of different enzymes that digest your nutrients. So it's going to help digest carbohydrates, protein, fats, but these enzymes have to get delivered. They get delivered to the small intestine. So the enzymes don't function in the pancreas, but they get delivered into the small intestine. So that's what 99% of the pancreas does, is produce those digestive enzymes. About 1% of it is endocrine. And the endocrine tissue is seen as little kind of patches of tissue in the pancreas. So they're just little scattered little patches of endocrine tissue. And in that endocrine tissue, there's different cells, because you need a different cell to produce a different hormone. And we're not going to get into all the hormones, but we're going to get into two very important hormones. And together, these two hormones, because they're antagonistic, meaning do opposite things, they're really good at maintaining your blood sugar levels. Okay, so this is going to look a little bit like calcitonin and parathyroid hormone, in that together one's going to be able to raise your blood sugar and the other one's going to be able to lower your blood sugar, instead of, say, calcium like calcitonin and parathyroid. Okay, so we're going to start off and just talk a little bit about a scenario. So one scenario you might have is you haven't had a meal in a while. Okay, so maybe you woke up, didn't have breakfast. All right, now it's getting 12, 1 o'clock. Your body needs blood sugar, right? Blood glucose is, your number one energy source. So your body needs enough of this glucose circulating throughout the blood. All right, and if you haven't had a meal, and it's 12 or 1 o'clock in the afternoon, you got to have someone maintaining your blood sugar levels. All right, because you're going to be still utilizing glucose for energy, but you're not bringing any more of that into your body. So the stimulus for the production of glucagon is low blood sugar. All right, so your blood sugar is low because you haven't had a meal. The pancreas detects that, and it uses cells called alpha cells. All right, so the alpha cells are endocrine cells of the pancreas, and they're going to produce glucagon in response to low blood sugar. Okay, glucagon has a really important primary target, and that is the liver. Okay, and we need to talk a little bit more about the liver. I kind of mentioned it in the previous slide. If you remember, epinephrine targets the liver. And both epinephrine and glucagon target the liver because it has stored up glucose. All right. So that stored form of glucose is called glycogen. All right. So glycogen is a carbohydrate. It's a polysaccharide, meaning it has a lot of glucose units. So it's a way we can just store that glucose for later. Okay? So what glucagon does is it goes to that liver and causes the liver to break down glycogen. Okay? Glycogenolysis. All right? Break down that glycogen into glucose, release the glucose into your bloodstream, and that'll keep your blood sugar levels up. Now, it's not going to boost them like epinephrine. So epinephrine does a similar thing to the liver, but remember, epinephrine is being produced in a fight or flight situation where you're going to need, not just to keep blood sugar up, you're going to need to let it go really high so you can get energy, more energy. All right. Glucagon's more to just keep that level up so it doesn't crash severely low. So you're still going to have kind of low blood sugar, but at least it's not too low. Okay. Now, the liver's really smart. It knows how to make glucose another way, and that's called gluconeogenesis. All right. In this method, it doesn't use glycogen. It can use other molecules like an amino acid. All right, so it has a way to take amino acids and convert them into glucose. So what this liver's doing is just trying to get you enough blood sugar until your next meal. All right, it's not going to spike it, but it's going to keep it from getting, dangerously low. So if you haven't had a meal all day, you have to thank glucagon, because glucagon's keeping you alive because it's telling that liver to keep releasing glucose into the bloodstream. All right. Hypersecretion, obviously, if you're producing a lot of this hormone, it's going to keep telling that liver release more and more glucose. So you might actually develop hyperglycemia. If you can't produce glucagon in a high enough level, you might have hypoglycemia, low blood sugar. Okay. Okay. Insulin. All right. Insulin, completely opposite. So instead of being stimulated by low blood sugar, it gets stimulated when you have high blood sugar. Okay, so this is going to occur right after a meal. So now, let's say it's 1, 2 o'clock, you finally decide to have a nice meal. That meal has carbohydrates in it. You digest those carbohydrates, you absorb those sugars, those glucose molecules, and now you have temporarily high blood sugar. All right. That's going to stimulate the beta cells, all right, different cell type, to produce insulin. Insulin has a broader effect, all right, where glucagon was primarily the liver. Insulin targets the liver, but also a lot of other cells, okay? And most cells of your body have insulin receptors. So here's one of those cells. So this could be a liver cell, it could be a muscle cell, it could be any cell. And it has that insulin receptor. There's insulin, attaches to the receptor. Insulin's a protein, so if you remember, it can't get into the cell. So it needs to find the receptor kind of sticking in the membrane. Once it binds to that receptor, there's some things that happen that this drawing doesn't show. But the most important thing to do is to open up the glucose transporters. So those are little proteins that bring in glucose. So this little white sphere here represents the glucose getting brought from the blood vessel, from your bloodstream out here, into the cell. So when that happens, right, you're moving glucose out of the blood into the cells, that's going to allow your blood sugar to go down to normal levels. Okay? And then, just as important, is now your cells have glucose, which this cell might use that glucose for energy, or if it's, say, the liver or muscle, it's going to take that glucose and convert it to the stored form, okay, glycogen. Okay? So in response to insulin, the liver does glycogenesis, right? Forms glycogen from glucose. In response to glucagon, it does the opposite, right? It does glycogenolysis. It breaks down the glycogen into glucose. So two opposite effects on those liver cells. You might have so much glucose you have to start converting it to fat. So the liver might say, okay, that's a heck of a lot of glucose, Cupkey. You've, really outdone yourself when it comes to, your carbohydrates. I'm going to have to start converting some of that glucose to triglycerides. And that's more of a longer term storage of energy. Okay? So insulin, again, now you're going to bring that blood sugar down back into the normal levels. You're going to store that glucose. You're going to utilize that glucose. And that's the function of insulin. Hypersecretion, I'm not really going to ask you about that. That can potentially be a response when you have type 2 diabetes. And I'll explain why in a little bit. But hyposecretion is the cause of type 1 diabetes mellitus. Okay, and we'll talk more about type 1 and type 2 coming up. All right, so there's insulin. This is one of my favorite figures. It's not from the book we're utilizing now. It's from an older book we used to use. Don't look at type 1 and type 2 just yet. I want to go through this figure. And, I'll remind you, figures are meant to kind of walk through, right? A lot of people realize students don't read, right? So textbook manufacturers used to make textbooks all text, right? Maybe a few pictures. The nice thing about A&P is you get nice pictures. Then they started to realize, well, students just aren't reading. What's another way to, explain this information where a student doesn't have to read too much? And they come up with these figures. And, don't be afraid of a complicated figure. But you'll notice a lot of my PowerPoints, all I'm doing is trying to explain a figure. All right, so this is a really good figure to help explain how insulin and glucagon work together to maintain blood sugar. All right, what this first is showing here is just a little area inside the pancreas. This would be like if you looked at it under the microscope. This is all exocrine glands out here, so these guys are making the digestive enzymes. This is called a pancreatic islet, or islet of Langerhans. It's a little, islet means an island, so it's a little island of endocrine tissue in the pancreas, but that's where you're going to find the endocrine cells. So some of these cells are beta cells, some of these cells are alpha cells. We don't care, we can't tell the difference, but those alpha and beta cells are found in this islet here. Okay, so we got two situations. You're either low blood sugar, so you got a little hypoglycemia going on because you haven't had a meal in a while, or you've got hyperglycemia shortly after having a meal. Okay, so let's start here. Low blood sugar, hypoglycemia, stimulates the alpha cells. All right, the alpha cells of the pancreas produce glucagon. Glucagon goes into your bloodstream. It acts primarily on liver cells, known as hepatocytes. And those liver cells are going to convert glycogen to glucose. All right, again, we call that glycogenolysis. So lysing or breaking down glycogen into glucose. And then it can also make glucose. I mentioned amino acids. It can also make glucose from lactic acid. But ultimately, these two bullet points result in releasing glucose from the liver into your blood to help maintain normal blood sugar. Okay? If you do this too much, there's going to be a negative feedback. All right? But we don't need to go there. All right, so now you have that meal. Right? That meal has carbohydrates. You got enough carbohydrates to hopefully last you a while, so you're going to consume kind of excess carbohydrates because you want to be able to go a few more hours without another meal. So carbohydrates get digested, they get absorbed. Now you have temporary hyperglycemia, and that stimulates the beta cells of the pancreas to produce insulin. Insulin has a broader effect, right? Not just, liver, but a lot of cells, liver cells, muscle cells, neurons, any cell of the body typically is going to have an insulin receptor. What does that do? it accelerates the facilitated diffusion of glucose. Basically, glucose goes into the cells. All right. You can either use that glucose or you can convert it to glycogen if you're the liver or muscle. And then it has some other effects on those cells as well that I'm not going to focus too heavily on. But together, this is going to lower your blood sugar, but more importantly, it allows those cells to now have glucose, and they can do whatever they want to do with it. Okay? All right, so that brings us to type 1 and type 2. What's the difference? Couple things. Type 1 is juvenile, so that's usually an early onset. So individuals get diagnosed earlier in life. It's also referred to as insulin dependent because that's the problem. All right, there's low insulin production. Now, what causes that is the actual loss of the cells. So the pancreas loses the beta cells. There's a lot of thought that this is an autoimmune disease where the immune system has destroyed the beta cells. And if you have low beta cells, you're going to have low insulin. Okay, what happens when you have low insulin? You can't do all of these things. Okay, so if you were to just say, all right, we can't do any of this, what happens? Well, you're going to have high blood sugar instead of low blood sugar, but you're also going to have low cellular levels. So now the cells don't have glucose, and that's a big problem. All right, this is basically like starving your cells. All right, they're not getting their energy, they're not getting their glucose. And sometimes these cells will start look for other things. So they'll start to burn more fat. The problem with burning too much fat for energy is you form these acidic byproducts called ketones. So you could develop what's called ketoacidosis. Your blood can become acidic from these ketones. What are some of the signs? So frequent urination. So think about, why would someone with diabetes urinate a lot? Well, what happens is because of all this glucose in the blood, a lot of the glucose ends up going into urine, and it pulls more water out of the body. All right, water likes to follow things, right? Water likes to follow salt. Water will also follow that glucose out of the body, and therefore the patient urinates too much. And if you're urinating too much, you're going to become thirsty. So a lot of individuals that get diagnosed with diabetes, they kind of have that aha moment. Oh, that's why I'm urinating all the time. That's why I'm so darn thirsty all the time. That's why I seem to be hungry all the time. It's because my cells are hungry. My cells are craving that glucose that they can't bring into the body. All right? Or bring into the cells. So that's type 1. Treatment, replace that insulin, right? One thing we know from hormones is if you have a low level of a hormone, let's manufacture the hormone and give it to the patient. So we can make insulin, and that's a whole nother story. It's genetic engineering, but we can make insulin and give it to these patients. All right, type 2 diabetes is typically later in life. Now we're seeing, younger and younger people develop type 2 diabetes, and it's largely due to poor diet, lack of exercise, and then there's a big genetic factor as well. So what happens is over a period of time of poor diet and lack of exercise, individuals have a lot of insulin production. So if you consume a lot of carbohydrates, especially the sugars, right? You're consuming a lot of sugar every day. Well, what happens is that pancreas needs to produce a lot more insulin every day, and to be able to bring that glucose down. So a lot of carbohydrates in the diet lead to a lot of insulin. And a lot of insulin production over time causes the target cells. So now we're looking at these target cells. They become resistant to the insulin. I like to think of it as, kind of when you become resistant to, someone complaining all the time, right? We all know someone who might just complain all the time. Well, after hearing about all these complaints, I don't know if you're like me, I start to become resistant to it, right? I don't want to hear it anymore. I'm not going to respond to it anymore. So the cells are kind of tired of hearing from insulin all the time. Geez, every day I get this insulin binding to my receptors and okay, now I got to bring in more glucose and I'm going to stop responding to that insulin. And that's known as insulin resistance. What results? High blood sugar, thirst, urination, a lot like type 1 diabetes. But there's often a lot of other major problems because, again, this is a chronic disorder where it's happened over a long period of time, and it can lead to sores, diabetic sores, heart disease. The eyes can be affected, called diabetic retinopathy. One of the treatments is metformin. Metformin actually targets the liver. It controls how much glucose the liver releases into the bloodstream, so that can help lower blood sugar levels. But really, the most important thing is diet modification. Try to start changing your diet and exercising more. Okay, so that was a lot. That's a lot of information revolving around the pancreas and those two hormones. We're going to wrap it up with the gonads. Like I mentioned, we get into the reproductive system a lot more at the end of the semester, so we don't need to go crazy here. What I want you to know about ovaries is they do produce some hormones. Estrogens, there's a couple forms of estrogen, that's why we say estrogens. Progesterone, you might have heard of progesterone, that's kind of a pregnancy promoting hormone. It kind of makes sure all the things that need to happen for pregnancy to occur will occur. And then a couple other ones we don't need to worry about now. We'll learn about them later in the semester, called relaxin and inhibin. So for now, we just need to be able to recognize that these hormones are produced by the ovaries and they're involved, right? They're involved in the female reproductive cycle, pregnancy. They get mammary glands prepared. They help develop the female sex characteristics. A couple of these, so if we give estrogen and progesterone, that can be used as birth control. So that's what this shows here. And we'll get into the mechanism on how that works when we get into the reproductive system. Same is true for testes. Just recognize the fact that testosterone is produced by testes. It also produces that other inhibin that we'll worry about another day. And testosterone and inhibin are involved in regulating sperm production and promoting the male secondary sex characteristics. And finally, we've got kind of a list here of other hormone tissues or hormone producing structures. Some of these we're going to learn as the semester goes. So I wouldn't focus on this slide much at all. But it's a way to explain to you that you're never going to be done with hormones. When we get to the heart, we're going to learn that the heart makes a hormone. It's known as atrial natriuretic peptide. It helps kind of keep our blood pressure from getting too high. Your GI tract produces a few hormones, so we'll learn about those when we get to the digestive system. The kidneys produce some hormones, and we'll get to this one actually in the next chapter when we learn about blood, because erythropoietin is going to help stimulate your bone marrow to produce more red blood cells. Adipose tissue produces a hormone. It's kind of involved in appetite control. It also is involved in the onset of puberty. Bones make a hormone. Your thymus produces a few hormones. The thymus, we'll be able to identify it now. If you remember, it's on that drawing sitting above your heart. We'll learn more about it when we get to the immune system. For now, that's probably all you need to know, is that the thymus is somehow involved in your immune response. Okay, but we'll talk more about that when we get to the immune system. Okay, so at this point, you are more than likely overwhelmed. All right, hormones is a very hard topic, especially to start off a new semester. So if you're starting to feel overwhelmed, that is completely normal. It's just a matter of getting started and do a little bit at a time. So I don't recommend trying to learn all these hormones in one sitting. I would sit down and work on, just the hypothalamus and pituitary. All right, just take one day and work on that. You don't have to move on to other glands until you have a pretty well understanding of the pituitary. Okay, and then the next day try to learn maybe the thyroid and parathyroid. If you try to do too much at once, you're just spinning your wheels and you're going to get very, very overwhelmed. Okay, so try to break down this whole PowerPoint into smaller, more manageable sections. Obviously, reach out to me if you're having any trouble. There's a lot of other resources you can use, but ultimately, I think you need to learn how to study a PowerPoint and study it the right way, which typically means using a pencil or a pen to write stuff out, maybe reading through the PowerPoint, maybe listening to these lectures a second or a third time. Once you learn hormones, it's gonna be a huge benefit for you because they're not going to go away. We're going to revisit a lot of them this semester, and it's one of the more important things to understand when you move into a medical program. One last thing is if you make note cards. If you make a note card with the name of the gland on one, or name of the hormone on one side, and then on the other side you put the gland that produces it, the targets, what the targets do, and any disorder that I mentioned, you'll have note cards. And one day when you're in, say, a nursing program or some other medical program, and they start talking about hormones, you got your note cards. All right, you can dig them out from wherever they are, and you can use them again. Okay, that's a really important thing if you're going on to a medical program, is to be able to access the materials you learned from. Okay, so that's why I think that's so important. Okay, get to work. Reach out to me if you're having any trouble. Look in the module. There's plenty of extra resources.